100 mm. Each grid is of 100 mm. So for that the sizing is given there. So you can see that your various sketch profile are here. Okay, sketch profile. Prior to that, I'll explain this. Sorry, I forgot that. We have 10 units over here. 10 units in the 10 modules, what we call, of Abaqus CAE. What this each module will do? Part is nothing but to create your geometry or import your geometry. Yeah, but whatever related to your CAD or a geometry are stored in this part. Okay, that is part module. Second is your property module. Property in the sense your material definition or material properties need to add. Whatever you take, that will be added into your property module. And next is assembly module. Assembly module in the sense you have 3 to 4 components you have been assembled. Those assemblies data will be stored in the assembly module. Okay, and the step in the sense here you will define which type of analysis you need to do it. Static, modal, that is your Abaqus always follows star step. So I'll say one more thing is any first star, any for Abaqus, star means read this sentence or read this line. Double star in the sense ignore this sentence or ignore this line. Don't count for your simulations. Okay, software follows this star as its command point. Okay, double star or empty are neglected. And one more speciality of Abaqus is it follows naming of that particular component. What you give a name, it will take that name as a ID or anything. The other softwares, like for example your Workman, ANSYS, APDL, or you take an Astron, they all follows a ID values. That means they know number systems, but your Abaqus knows naming system. Okay, so I'll show that once it is done, how it will be as in your deck. We call your coding, whatever the code we write, that as a deck here. Okay, and step interactions in the sense, in this interaction you will be having all the type of contacts, generation or interaction, predefined loads or predefined structures, whatever extra loads or point loads need to be added or connecting points, everything will be stored in the interactions. Whereas a load, you know that load and boundary conditions, point load, pressure load, any loads which will be in the module system. And the mesh is nothing but your discretized model. Your finite number of points to be solved are called as mesh, what we call. So this mesh will be stored in your mesh module. The other is optimization module. This comes after your simulation. Any component you need to optimize, so that will be stored in the optimization module. Next is job in the sense whatever the step has been defined, that will be solved in this job. That means a simulation will be done in this. Visualization is your post processing in the sense visualizing your results. Again, in the results we have two type of format. One is ASCII format, one is binary, other is a binary format. Okay, ASCII format is nothing but your typed in a numbering format, okay, or your text pad format. Whereas other is binary format is your visualization. Why we call as binary format is your system takes 1010 as a equation to give you a result or visualization. So results will be of visualized here. And the third is sketch. So whatever you do here in the module, so that will be given in a sketch module. Okay, and the model is here, which model you are presently looking into. In the same thing you will be having different number of model, so that models can be visualized here. Part, again different parts for an assembly, so different parts will be there. Again here you have a view formats all. XY format directly, as similar with other softwares, as you know that CATIA or any tools you have used, or your SolidWorks. So I have different sketching view angle, isometric view, other things. Okay. So for first, I'll be taking as a rectangular. I'll consider this. Just I'll draw one and take a center at the hole as a center point. Okay. So what I'll do, I'll finish this, pick any center point for the circle or enter X, Y, Z. So I have taken directly here. If you don't want that, you can undo as like Control Z as in your undo. You have done it, but some mistake has been done. You want to delete it, just go give Control Z. You will get an undo value. Okay. Now I want this point at 0, 0, 0, comma 0. Okay. Now where do you require? If you have a coordinates, you can give it perimeter or values. So just have clicked it. It has been shown. Now the plate with hole has been generated. For this, close this and sketch the section for solid extrusion, because I have used there as an extrusion. I am getting this as an extrusion, solid extrusion. So if I give a done, so it will ask what blind do you require. So how much thickness you require for your sketch. So I will take here as a 200. So now you can see this 200. Now I want to edit this. Go to part, features, solid extrusion. So 200 is more, I require less, only 10. So click that, you'll be getting your different size. So I'll take as 2.5 because it will be less thicker. Okay. So then you can see that you have got a model. And how do you rotate your model? Your right click mouse button and control to rotate your geometry. Left click and control is to pan your geometry. Center button, zoom in, zoom out. For that you need to hold your control button for all the three. Yes. So for that. So now this geometry is being generated. Once the geometry is done, the CAD model or your CAD has been imported directly. Now what next? Next is go to property, add a property material to that. So this, create a material. So what type of material you require? So here a various is there. I'll explain for what required for you people now for this problem. For material, I'll take this as a steel. Okay. For steel, I'm doing a modal analysis. For that, what I require? I require typically as an elastic material. So that is E and mu. I am considering my material is under elastic limit itself. So for that, I need to add Young's modulus and Poisson's ratio. You can also take a density as an optional whenever you do a G cases or dynamic analysis. You require a density. So what I'll do, go to general and click on to density. So this is distribution is equal in the sense every point has a same density. So what is our density for steel? Anyone? It is 2700 kg per meter cube. So when I convert that to tons, so it will be like 2.7 e raised to minus 9. Okay. So you can do that. You will be getting that 2700 kg per meter cube as tons per mm cube. So that will be 2.7 e raised to minus 9. So I have taken the value 1 density. And next, elasticity, Young's modulus. What is an Young's modulus? 210 GPa, right? So I require that in MPa. So what I'll do? 2100000 210 megapascal. Okay. So then what is your Poisson's ratio? I'll consider 0.3 as a Poisson's ratio. By this, your material has been given a values. Okay, so what I'll do, I'll close this. One second. My screen is short of focus. Options.